Alright, welcome again in another tutorial of the topic differentiations. So in this tutorial tunaendelea pale tulipoishia pale kwenye maximum and minimum values, okay? So it's like mwendelezo wa pale. So now consider this function, okay? Consider y is equal to x minus 1 cube. And so we have 12x squared minus 9x minus 43. So I want to find dy dx, okay? So this function is like a product of two functions, okay? So I use the product rule, okay? So, remember the product rule says if y is equal to uv, dy dx is just u dv dx plus v du dx. So this was the product rule. So in this case here, my u is x minus 1 cube, and my v is this one, 12x squared minus 9x minus 43. So if I differentiate u now with respect to x, nita differentiate haraka haraka. For detailed information on how to differentiate this, visit the tutorial derivative of composite functions chain rule. Kwa hapa ndapata 3x minus 1 squared. And dv dx now is just going to be equal to 24x minus 9. Ukitaka kujua jinsi ya differentiate hii kwa undani, visit tutorial inaitwa derivative of polynomial function. So okay, hii naweza nika simplify further. This is just equal to 3 kitoa nje there, okay? So my dy now dx is going to be equal to u is x minus 1 cube times 3, 8x minus 3, plus v is 12x squared minus 9x minus 43 times du dx is 3x minus 1 squared. So what a very long algebraic expression. I have to simplify it. So I have 3 here and 3 here. I have x minus 1 squared, I have x minus 1 cubed. I can factor out x minus 1, 3x minus 1 squared. So my dy dx now is just going to be 3, so I factor out x minus 1 squared. I remain with x minus 1 times 8x minus 3 plus 12x squared minus 9x minus 43. Like that, okay? So, huku ndani hii naona nitabidi ni expand ili niweze kujumlisha, okay? So my dy dx is equal to 3 x minus 1 squared. So x times 8x napata 8x squared minus 11x plus 3. So we're going to have plus 12x squared minus 9x minus 43, like that one. So my dy dx is just going to be equal to 3x minus 1 squared. So 8 plus 12 is 20x squared. Negative 11 minus 9 is minus 20x. And 3 minus 43 is here up, okay? So now I can factor out 20, okay? Niki factor out 20 times 3 inakuwa ngapi? 60. So dy dx itakuwa sana 60 x minus 1 squared. Kwa hiyo ndani nabaki na x squared minus x minus 2. Lakini huyu x squared minus x minus 2 nikimfactorize ni sasa niseme x plus 1 times x minus 2, okay? So finally, my dy dx now is just 60. We have x minus 1 squared, and then we have x plus 1, and then we have x minus 2. Like that. Okay. Now, nikitaka nipate maximum or minimum values, or points, I need to find the values of x when dy dx equals to 0. Kwa hiyo hii sasa ndo my dy dx, okay? It's gonna be equal to 0. So you see kwa nini simplify pia hivi? I can very easily get values of x hapo. So you can see x itakuwa sasa na 1 kwa sababu 1 minus 1 ni 0. X sasa na negative 1 and x sasa na nani? Na 2. So we have negative 1, 1 and 2. Kwa hiyo huyu ndo mdogo kuliko wote, afa anafuata huyu, afa anafuata huyu. Now I want to determine, so these are my turning points, okay? These are TPs, turning points. I want to determine which one is maximum and which one is minimum. So let's start with x is equal to negative 1. So I mean dy dx is 60, okay? So we have x minus 1 squared, we have x plus 1, and then we have x minus 2, like this now. So tuanze na x is equal to negative 1. Sasa x, tunajua ili point iwe maximum, dy dx needs to change from positive to negative. Na ili iwe minimum, dy dx needs to change from negative to positive. So let's see. Ile inaitwa x is equal to negative 1, okay? Hapo dy dx ni 0, okay? We have seen that one. So what about when x is less than negative 1? What's our dy dx? So nikiweka less than negative 1 maana kama negative 2, okay? Nikiweka hapa negative 2 inakuwa negative na negative. So it's positive. Because negative times negative is positive. Okay, tuona negative 2 plus 1 is negative 1 times negative 4. Negative 1 times negative 4 is positive 4. Wakati hapa is always positive kwa sababu ya square. So now we want x to be greater than negative 1, okay? But less than 1 kwa sababu point ya pili ni 1 na yenyewe tutaichunguza, okay? So we want x to be greater than negative 1, okay? But less than 1. What's my dy dx now? So ipo kwenye nini hapa? Kwenye 0, okay? Naweza ngeka 0. So 0 ni positive, negative. So it's negative now. So this moves from positive to negative. So this point is a what? Is a maximum point. Okay, what about x equals to 1 now? Inafuatia hiyo. So we want x now to be less than 1 but negative 1. Okay, tushaona hapa kwamba dy dx is just negative, okay? So now we want x to be greater than 1 but less than 2 kwa sababu tuna point nyingine hapa x is equal to 2 na yenyewe tutaitest. So dy dx ni 1.5 hivi, okay? So hapa napata negative positive, kwa hiyo itakuwa negative. Look, hii ina move from negative to negative. This is new. Now I'll talk about it in the same ref. So when x equals to 2 now, my dy dx is equal to what? 0. So now when x, okay, is less than 2, less than 1, okay? dy dx tushaona is just the same, negative, because na test kwenye equation hiyo moja. So what about when x is greater than 2? What's my dy dx, okay? So tunaweka hapa like 3. 3 minus 2 is positive, 3 positive, okay? So inakuwa ni positive. Yani manake pachika any value greater than 2 in this equation, you get positive. So this now, it moves from negative to positive. So this one is a minimum point. Sasa tujaiongelea hii. Hii sasa, it is not minimum, okay? It is not minimum and it's not maximum. Because it's neither minimum nor maximum. So what is it now? But it's a turning point. It's what we call the point of inflection, okay? Kwa hiyo hii sasa ambayo x equals to 1 ambayo sio maximum na wala sio minimum is what we call the point of inflection. Let me draw the graph now. You can see it, okay? So it's like this. So I mean I have my y-axis here. So this one now is my y-axis. And then I have my x-axis here. So I have my x-axis here. So this one now is my x-axis, okay? So turning point zangu zilikuwa x is -1, 1 na 2. So let's say my y value when x is -1 ni hapa, okay? So dy dx will move from positive, manake graph ina increase kwenda nini? Negative, you see? So this one now is my maximum point, okay? So it moved from positive to negative. Okay? Lakini hapa sasa kwenye point of inflection, so hapa kwenye point yenyewe dy dx ni 0, okay? You can see that the tangent is parallel to the x-axis. So hapa sasa manake decrease. Ilipofika kwenye 1, it means it has to be flat, okay? So that the tangent is 0, okay? So it moved from negative to what? Not to positive, to negative again. Okay? So this one is a maximum point. This one now is what we call the point of inflection. So hukuje, let's say ni hapa, it moved, so it decreased. My dy dx moved from negative to what? To positive, manake inafanyaje? Ina increase. So this now, hapa kwenye ni 0, okay? Ni nini? Ni minimum point. So when dy dx is positive, the graph of y increases as x increases. When dy dx is negative, the graph decreases as x. The graph of y decreases as x increases, okay? So at the turning point, the slope, the dy dx is 0, the gradient, okay, is 0, because the tangent at that point is just parallel to the x-axis. Now when the gradient changes from positive to negative at the turning point, it's a maximum point. From negative to positive at the turning point, it's a minimum point. When there is no change in sign at the turning point, that point is what we call the point of inflection. So hizi njia za kutafuta maximum and minimum point nifundisha nyingine kwenye ile tutorial ya maximum and minimum values 2, ambapo ilikuwa ni kufind second derivative. Sasa ipo hivi, tulikubaliana kwamba ukitafuta second derivative, okay, ukapachika value ya turning point kwenye second derivative, jibu likija negative, basi ile value uliyopachika ni maximum point, okay? Ukitafuta second derivative, okay, ukapachika ile turning point kwenye second derivative, jibu likaja positive, basi hiyo turning point ni minimum point. Angalia ile video ya maximum and minimum values 2. Okay? Lakini sasa kwa point of inflection inakuwaje? Ukipachika ile turning point kwenye hii second derivative, jibu likaja 0, then hiyo ndio inaitwa nini? Point of inflection. So I mean you can test it kwa hiyo ambayo tumetoka kufanya. I don't want to do it because the second derivative will be very long to solve it here. I don't want to do it, but this is the bottom line. So let me just say, see you in the next tutorial.